Alright, welcome back to Meteorology 101. In this video, we're just going to basically do a surface analysis. We're looking at satellite right now, so we're just going to go through the next few days. Looks like possible severe weather coming up. We're going to try to analyze that system a little bit and go from there. So right now what I'm looking at on satellite, I can see, get my tool up here, low pressure over the southwest. You can see that rotation around that low. I see a little bit of curvature to the north. So if we have a front here, we should have warm air advection from the south. We can see all that moisture coming off of the Gulf. So we definitely got high pressure over the southeast. So if we're rotating around the high, we're bringing all that moisture off the Gulf, wrapped around that high. We can see our ridge right here. So here's all the cirrus spilling over the ridge. This looks like maybe a little bit of rotation up through there, or just an unstable wave, and a little bit more possible warm air advection up in that area to the north. So we got a low here, low here. We got to have ridging separating that. So we got ridging to the west, troughing to the southwest. Let me clear this off real quick. We'll start that one over just real quick. So ridging, troughing around that low, ridging over that high, and then troughing right up into that system. So we got the low pressure system to the northeast. That's well to the north. And then looks like our frontal boundary, I would say this is an occluded low. This is supposed to be purple, but we're just using for educational purposes. That's the excuse we use when we use the wrong colors. So cold front should be blue. Let me get it switched over there. So we can go, there's a frontal system that moved off, well off into the Atlantic. Possible post-frontal trough right behind that front. And then looking at these streets going through here, I would say the upper level winds are perpendicular to the front, so we're getting a lot of dry air pushed in and then causing these streets into the backside of that low. So not real concerned with this system. That system's just going to move off to the northeast. We're looking at this high. We clear this off every once in a while, keep from getting so cluttered. Watch that high pressure system. We're going to watch that move off. May go easterly, a little northeasterly, all depending on that jet flow. So your jet's right here. So I would point that a little bit to the northeast. As that moves out of the way, this low pressure system is what's going to take over. So with all this warm moist air coming off the Gulf, that's what we're going to have to keep an eye on. We'll go onto the surface chart. We'll look at the dew points and see what kind of moisture we got in this area, and see what kind of severe weather possibility we have for the south. So definitely have the low right there. Looks like warm air advection right through this area. And if this was a low, a frontal system, we could go almost go occluded, or depending on the depth of that low and how well developed it is, if we go occluded or not. And then we'll have to look for the thermal ridge for the occlusion, but we definitely got a little bit of a cold front right there. And then definitely warm air advection in this warm sector. That's what's causing all that moisture ahead of this front, is all that warm moist air being pushed off the Gulf. So we pretty much established that. So let me get rid of this. Let's go to our surface chart. Okay, so we're going to pull up sea level pressure. This will show us where the current lows and highs are. So we got our data, latest data from weather observations weather observations are sent out every hour. So we download that data, and then this program will analyze that data, and that will show us our high and low centers. So we could place these systems. So I'm gonna go put the isotherms on here. That's the lines of equal temperature. So if you're just joining my channel, we do cover pretty much in depth on weather systems. Now the isobars are lines of equal pressure, isotherms are lines of equal temperature. So if we look at this system like we were talking about in the south, let me turn my tool on here. Okay, so there's that low over the south. We definitely have warm air advection. Let me get the right color here. Try to get a red. We definitely have warm air advection in this area. We have all that warm moist air being pushed from the south. You can see where those isotherms cross the isobars. That is where our warm sector is. So we have our thermal advection right in that area. So we look behind this low pressure system. We got a cold front. So that would probably stretch back, maybe come down and wrap around a little bit. But we have, if you look where these isotherms cross the isobars, we know that the wind rotates counterclockwise around the low, and that's pushing this colder air into the warmer air. So there's our cold sector. So we got a cold front, leading edge of that cold air mass, warm front, leading edge of that warm air mass. Now the low to the north, that's like an inverted trough up out of this low pressure system. That's the parent low. This is just troughing, reaching all the way up into South Dakota. So if we keep an eye on that low, we got some thermal advection there. We've seen that on the satellite. That's our warm air advection. Not really any cold air advection behind it. Let me go ahead and erase that. So because these isotherms are more parallel to the isobars, so we're not really having any cold air advection right there. Because what would happen if we did is that cold air started advecting into this low and just start filling that low and cause it to weaken. So I don't see that happening. This is just this low pressure system's just stretching all the way up into South Dakota. We got that warm air advection, so we should look for some weather in there. We got a pretty tight thermal gradient right there. Our thermal ridge is more or less right here. We're not we could possibly go occluded, bring an occlusion up out around into that ridge. I'm not really seeing that too much. I would almost want to drop that cold front down, and then we could probably go a little bit of an occlusion there, and then the warm front, I'll go ahead and erase that real quick. The warm front would be the leading edge of that warm air, that warm sector, the warm air advection. So bring this down back around this way. So you could possibly have just a slight occlusion with that low. I mean, it is a 1004 millibar low. 1003 is the center. So once we get into the 990s, I would probably go a little bit more deeper on the occlusion. But this one, we know our flow. We had that trough, we had that ridge from the jet, the trough for that low, the ridge, and then the trough coming into that system up to the northeast. So there's our ridge from a high pressure system, trough from the low pressure system. We have to get into the upper levels, see how far this stacks back. If it's closed at the 850, is it an open low? Is it just a major short wave? What's the support for this low? And then we know our jet stream is pretty much following this pattern. So this low pressure system should push to the northeast, as that high should continue to the east, northeast, and then as this one develops, we'll see it will probably just absorb this low and then continue to push to the northeast and bringing all this moisture with it. So we are going to look at rain showers pretty much throughout the Midwest, probably for the next few days. We'll have to we'll go into some models, look at that, see where we end up there. So clear that out. We'll pull up the station plots and we'll take a look at our dew points. We'll see what's going on down here in southern Texas. That's going to give us an idea how severe this weather's going to be. So we know we got 20 knot winds, 15 knot winds, low ceilings, already rain over northeast Texas, and then marginal VFR ceilings are less than 3,000 feet right there, and we have dew points. There's a 69, 56 in Mexico, 28. There's where we're drying out pretty good. So that's the area, probably the edge of the pretty much our dry line right there. So 58, 58, 50, 44. We're looking for, there's a 68 right there, 68, 69 right there is our area of concern. So right there, 58 or 68 and 69. So we got the upper 50s right here, which is okay. Upper 50s is there, so you can pretty much count this whole area. There's a 58 being an area that could produce severe weather. Now, as that low pressure system moves to the northeast, now all this moisture moves with it, then you could pretty much forecast your severe weather area the next 24 hours right over Louisiana, Arkansas, maybe Mississippi. We'll see what the SPC puts out on that. If you want to do a composite chart, it gets pretty intense. It's not hateful to do a composite chart, but analyzing every level and then bringing them down to one level, and you can actually pinpoint your area of severe weather. But all of the models we have today and the SPC, let them do their job. You can just go look at theirs, and they're pretty accurate on that stuff. I mean, they do get like an enhanced area, a slight area, so they take their cones out kind of far sometimes to just cover their bases. I mean, if there's a possibility of any severe weather, they'll do that. But I would definitely say they probably have an area in the south for severe weather, just based on those dew points. And with that low pressure system, the winds for the south, all the moisture, you have every ingredient you need for severe weather along the Gulf states. I'll get rid of that. Okay, so this program will put fronts on here for us. We can do that. It gets a little cluttered. Let me this one ain't too bad. I'm not going to erase it. We only got a high and a couple lows, so because this will overlay more lows and then put the fronts on, and sometimes it gets a little cluttered. Let's see what happens there. The low pressure system over South Dakota with a little bit of a warm air advection. It's trying to go stationary because you see that blue, but I would bring this warm front out to the leading edge of that warm air advection we talked about. I would bring that as a warm front. They got a cold front stretching out of that low to the south back into this low pressure system. That's just coming all the way back behind that low, so that's completely wrong. You do have a mountain range right here, so the computer gets a little confused on that because it almost looks like a lee side trough all the time at that low. The separation between air masses looks like a boundary sometimes to the computer based on the data. So if I would bring, we have no thermal advection here. So let's look at, we got a wind out of the north, wind out of the south. So we got to have a boundary, but I would put leave that cold pip there, go warm, and just make that a stationary front, stretching down into this system, if we had to do that, or just leave it as a trough. It really doesn't matter. But with this, wind shift that we had, I would bring that as a stationary front, just because the wind shifts are opposing each other. Those wind directions are opposing each other, so that would be indicative of a stationary front. Now, this warm front that got stretched out of here, that's okay. Let's look at our winds. We are going southeasterly and then southerly, so that warm front kind of does stretch across in that area. I can agree with that. The cold front, here's a southwesterly flow, northwesterly flow, so I would bring my cold front back through here ahead of that cold air advection, just like we talked about earlier. So, and your warm sector is pretty much right through there. So I would not put an occlusion there. That's, the computer didn't do it. I'd say that's correct. Not until that develops a little bit more. There's a thunderstorm, rain out ahead of this low. All that warm, moist air we've seen on satellite coming up. High pressure dominating the southeast. That's where all the clearing is. And then we have all this warm or cold air advection where that cold front was stretching down well off the coast. So this is a system to keep an eye on. But watch that move to the northeast, all that warm moist air, and then what we're looking for, these dew points, we look for our severe weather area to be right along as that warm front pushes to the north. That's where our severe weather should end up. Alright, so let me clear this out. Now we'll go to the 850. Let's look at that low pressure system at 5,000 feet. Still a closed low, so that system is pretty well developed. Still have thermal advection, so we could almost place an upper front right behind that cold front that we had stretching to the west, and then there's our thermal ridge going up into this low, which that low pressure system's pretty much an open low, so that's a weak, like we said. That could be a inverted trough or just a low just stretching up to the north. So this low pressure system is almost vertically stacked. It does have thermal advection, but it's still in the early stages. It is developed pretty good because it's closed at the 850, so it will, as it continues to develop, that's giving us a sign that this thing could go pretty strong as it pushes to the northeast. Plus, with all that warm moist air, that's just going to deepen the low. So let me get the upper data on this thing. So we don't have as much upper air data as we do on the surface, because not every surface station lets go of a weather balloon to do the radio sound data. So southerly flow 50 knots, so that's a low level jet there. That's another indicator of severe weather. So as we move, this low pressure moves to the northeast and we get this low level jet interacting. That's just going to cause exhaust for this low pressure system, cause it to deepen, and we do have low level wind shear based on that low level jet. 55 knot winds and 40 knot winds to the north. So we got some wind shear in that area, low level wind shear. So there's where your possible tornado activity, just based on the low level jet and the wind shear. So something to keep an eye on that. Let's go up to the 700. See what this low looks like at 700 millibar. Still closed. That's a pretty good system. Looks like it's stacking back to the west just a little bit. So we're starting to get our stack on that low pressure. So as we have our stack, we still have thermal advection. And with the jet stream, we'll pull up the 300 millibar jet, see what kind of jet support we have. We know we got jet support because looking at that satellite with that ridge and then that deep trough, it's a pretty deep trough in the upper levels supporting this low. So this is a pretty intense system, and it's just going to get more intense as it moves to the northeast. So we'll get into the models. Keep an eye on that. We just got to look at this ridge. This ridge is going to have to weaken. It's going to have to get out of the way for that low pressure system to do anything. So we'll pull the models and verify what's going to happen there. Let me get the station plots on this one. We can look at the winds. So as we've seen, we had 50 knot winds, 50, 55 knot winds in the south on the 850. Now we're getting a little bit weaker and at 700 millibars, which is about 10,000 feet. So we got the low level jet. That's at the 850 with that low level jet. We're looking at severe weather in the south and then like I said, possible tornadoes. We'll definitely see some tornado warnings over the next 24 hours. So these station plots that are colored in, that's where all your moisture is. We'll do a chart. I'll run one to pull moisture on these things, and we get a little bit better picture too. We'll do that a little bit later just for fun. And then we're going to the 500 millibar upper levels. Very important chart. Everything is pretty much looks at. You get 1,500 millibar thickness chart, 500 millibar troughing. That's going to show your major support for those surface systems. So if you're at the 500 millibar level and you show that support, you can pretty much say that is a very well developed system. So let's get our height on here. Let me make that a little bit darker. Close low. Still got a pretty strong ridge over that high pressure system. That's why these we have clear skies all the way up to the upper levels in the eastern United States now. So still close low on the at 500 millibars. So that's pretty impressive there. This system, as it moves over with that warm moist air and that low level jet, this is definitely going to be one to keep an eye on. Now, if you can see in the upper levels, we start to go more barotropic. So now the isotherms become more parallel with the contours. So we don't have that thermal advection in this upper level. We do have the stack. We do have, I'm sure we have jet support. We have the upper level low closed off. So that's a pretty intense system, but we start losing this advection. So we will look for low level tornadoes. There's a nice thermal ridge. That's a pretty good thermal ridge for support. As we move to the northeast, we're going to see this advection start developing in this upper level just by looking at this thermal ridge and when this low pressure system pushes off. So right now, by no means is this a weak low, but the upper levels is starting to get weaker, and this is more of a surface low for the intensity with the low level jet and looking for tornadoes just on the ground. If you had all the action in the upper levels, you'd look for funnel clouds, and you could get a lot of severe weather in the upper levels. Rotation, they'll still set tornado warnings, but a lot of that stuff wouldn't hit the surface. So station plots on this one, we'll take a look at those winds. Still 40 knots, 50 knots. I mean, this is pretty weak for this about 18,000 feet is where we're at now. Just over 18,000 feet at 500 millibars. So still getting pretty intense. I mean, we are over the mountain range over with this low pressure system. So as that moves east, we will definitely see a lot of intensification on that system. And one more chart, we're going to go to the 300 millibar, and we're going to pull up the winds. Look at our jet stream. A lot of wind on this chart. Typically we don't get that much color, but we got an open low now. We do have thermal advection in to the east of that low. There's a thermal trough. Here's the deep trough. It is a major shortwave in the upper levels, so the computer's placing a low there. It's not closed off, but it is a deep, very deep low pressure system. We can see on the satellite, we see it on a ridge, and then that deep trough coming around on the jet stream, and then ridging, and then went back to troughing. So we do have our ridge support for that high pressure system all the way into the upper levels also. So that's a pretty intense high pressure system too. Okay, there's our station plots. Now we're looking at 70, 80 knot winds. Our jet maxes to the northeast, we got up to 125. Pretty much could be it could be up to 127 knots up there. But, so if we look at our jet, we do have a deep trough supporting that low, upper levels, and then we do have here's a 110 knot wind right there. So we do have pretty intense support for that low pressure system on the surface. So we stack all the way up to 30,000 feet. So we still got the ridge support for the high, but so the high is going to have to move off for this low pressure to move in. High pressure will always rule low pressure. Low pressure can't move highs out of the way. Only a high can move a low, or the high is going to have to get out of the way for the low pressure system to move in. So that's what we're going to have to look at on the models and see how this ridge, if it weakens. But I suspect that with the jet stream support in the flow, that high pressure is just going to continue to move off, and then this low is going to move over. And with the low level jet and the warm moist air, and we have moisture all the way up in these upper levels too. All these black stations are overcast. That's saturated air, so we're pretty much saturated all the way to the upper levels. So we got the moisture. We have every ingredient we need for a system of severe weather. Alright, so I'm going to go to, let's look at the SPC real quick. This is going to be valid 13Z today to 12Z tomorrow, Tuesday. So you're looking at Eastern Texas. You got an enhanced area of severe weather. Outside of that, a slight area, a marginal area, and then, like I said, they'll bring these cones all the way out pretty far if there's anywhere there's a chance for severe weather. But we look mostly toward the center of this, and then anywhere that slight area is where you can pretty much say that there's a very good chance there's going to be severe weather. So Eastern Texas throughout 12Z tomorrow at 7 a.m. So looking at overnight pretty much throughout today and overnight tonight. And watch for tornadoes pretty much on the radar. We'll pull a local radar and see what's going on down there now. But for now, let's pull a national radar, and we'll get a good idea of what's happening throughout the U.S. for the precipitation. All right, so this is Intellicast.com. This shows the different types of precipitation. You can see snowfall in the upper elevations of Colorado, and then we have, looks like just some rain showers, maybe some small areas of convection throughout northern Texas into Oklahoma. there's just some isolated areas of convection there, and then you get your uh, snow over the Great Lakes region, and really where that warm front was coming out of South Dakota. We had that warm air advection to the north, so we did have that precipitation there, and then we had that system over the northwest also. Let's get over to the models. All right, so let's get to these models and see see how the system develops, where it moves to. So this is lining up pretty good as far as that low pressure system over South Dakota, the low pressure system over New Mexico to southwest of the Four Corners, and then we have all that warm moist air precipitation right there over eastern Texas. So this is just precipitation types. It's not convection, so it's not really going to show us like areas of severe weather. So keep that in mind. We're just going to see mainly just precipitation. So let's forward through this. Got that low pressure system. Let's keep an eye on this. We got the low pressure system just moving to the east. Starts moving to the northeast. The high pressure system moves off. But this low pressure moves over Missouri, northern Illinois, and then up into the Great Lakes region, and becomes pretty intense. And it looks like maybe some snowfall wrapped around the backside of that low also. So some snow showers and possibly in Missouri. Let's see what kind of temperatures that is pulling out of the north, to see what to drop that surface temperature enough, or drop that freezing level enough to cause snow showers. So this definitely becomes occluded. The cold front moves off to the northeast. Like I said, that one didn't show any. We're going to back this up. Didn't show anything severe. Looks like a little bit of heavier rain over Louisiana, Mississippi. Then just rainfall pretty much throughout the whole Midwest. That low pressure system becomes pretty intense, and then lake effect, a lot of snow in the Great Lakes region, and then that low pressure pushes off. So it looks like high pressure ridging in, but right behind that, because that's the leading edge of the cold air mass. So that ridges in, clears us out for a minute, and this is into we're already past Sunday night into Monday, so we're a week out already. So let's go all the way back. Let's start back over. I want to see my dates and times. We're pretty much today, 15Z, that starts at 10 a.m. It's 1 o'clock Eastern right now. So as we push through, now we're into Tuesday morning. Now we're pushing into Wednesday morning. Then Thursday morning. So you can see it takes a few days to get to this, to get over to the Great Lakes region. So the next 24 hours is what to watch for eastern Texas. I would suspect the next day, the SPC would probably put a warning out a little bit further east, and then maybe even over this area for Thursday into Friday. And then we got, looks like some isolated snow showers to the north, Indiana, Ohio. Probably not going to happen that way. This gets pretty far out. This is 126 hours out. So severe weather, you're only looking at 24 to 48 hours. You're going to get a real accurate forecast off severe weather. And then these models, you're going maybe 5 days out. Anything past that, it's a guessing game. It just has to make sense. So as this high pressure still pushes warm moist air off the Gulf, this system right here looks like another low pressure system coming out of Colorado off the lee side of the Rockies. That could actually interact with all this warm moist air being pushed off the Gulf, and then cause another area of possible severe weather. And then with that low moving through Kansas, and then to the northeast. We can keep an eye on that for possible severe weather over the next. That's like a week out. So that's pretty much it. We just watch these lows just continue to develop and push through. So it looks like it's going to be pretty much springtime. Looks like we are going to have a rainy spring to start. So I'll try to get another video out, and we'll try to go through some of these systems, what types of lows and highs and stuff like that, and get a little bit more into the meteorology side of it, and into the weather books. So if you like the video, just like, subscribe, share, and until next time, get your head in the clouds.